Alright, so your quarter 3 final, we're done with quarter 3. It's going to end on Tuesday. So we're going to have your quarter 3 final on Friday. And for notes, you can use notes on the quarter 3 final. You cannot use this, and you cannot photocopy this. And use a photocopy. That's kind of caught on like wildfire. So any notes you've got, or the handouts in class, or anything you've prepared from hand. So spend some time making good notes, because anything other than that will not be allowed. Okay, number 1. So trig, your eyeball should see the 30 and recognize that it's a 30, 60, 90 and a 30, 60, 90 and a 45, 45, 90, you know inside and out. So 30, 60, 90 comes from an equilateral triangle. All 3 sides are the same. So if you draw the other half, it kind of makes it easy to identify which sides are which. So this is 5 square roots of 2. This also is 5 square roots of 2. Together, 5 square roots of 2 and 5 square roots of 2, they're 10 square roots of 2. So every side is 10 square roots of 2. And then to go from, to find y, you always take the short guy, 5 square roots of 2, and you times it by a square root of 3. So y is going to be 5 square roots of 6. Okay, this one, the 45, 45 90 is half of a square. The other half looks just like this. We have the diagonal, 3 square roots of 6. So to go backwards from the diagonal, I'm going to take that 3 square roots of 6 and I'm going to divide it by square root of 2. Because to go forward, if you had n or m, if you had a side length, then all you do is take that side length and you times it by square root of 2. So to go backwards, we've got to divide by square root of 2. Okay, these play together since they're both under radicals, so it's going to be 3, 6 divided by 2 is 3. And there you go. That is m and n. Because they are both congruent, they're the same. Okay, same thing. It's a 30, 60, 90. Draw the other half. And if we know the altitude, we got to work backwards to get the shorty. And you're going to take the altitude, 4 square roots of 3, and you're going to divide it by square root of 3. So it's just going to be 4. So that means x is going to be 8. Okay, one more. 45, 45, 90. Your other half looks like this. Y is going to be 4 square roots of 2, and x is going to be 4 square roots of 2 times the square root of 2. So it's going to be 4 square roots of 4, or it's going to be 4 times 2, or it's going to be 8. Okay, now we're going to get into the trig. So these are not special triangles. These are just kind of any triangle, but they do have a 90 degree. So I am going to work off of angle B. If I work off of angle B, this is going to be my opposite. This is going to be my adjacent, and this is going to be the hypotenuse. So it does not matter which angle you work off. Angle B is no easier than angle A. So it does not matter which one you go from. But we do need to find angle B. We do need to find angle A, and we do need to find side C. So I'm going to find angle B first. And I'm going to use the trig ratio of tangent because I have 13 and 6. I have opposite over adjacent. So I know that the tangent of angle B is going to be opposite over adjacent, so it's going to be 13 over 6. And now, if I have the fraction, but I do not have the angle, I need to solve for B. The only way you're going to ditch the tangent is the inverse tangent. So I'm going to do the inverse tangent of 13 over 6 and make sure your calculator is in degrees. And that should give you 65, let's round to the nearest tenth, 65.2 degrees. So angle B has got to be 65.2 degrees, and then angle A is going to be easy. I'm just going to do 90 minus angle B, and I should end up with angle A's got to be 24.8 degrees. Okay, now I'm going to stay with angle B, and I'm going to try and find the sine. So the sine of angle B, but now I know the sine of 65.2 degrees. So the sine of this angle equals opposite over hypotenuse, so it's going to equal x over, no, it's going to equal 13 over x. Okay, now I want to find x, so I'm going to times both sides by x, and that gets x out of the denominator. So now I got x times the sine, 65.2 degrees, that's equal to 13. So I'm going to solve for x, I'm going to divide this by sine of 65.2, divide this by sine of 65.2, and then x is going to be whatever 13 divided by sine of 65.2 is, and that is about 14.3. Okay, so the thing to remember is if you do not have any angles, you have to use the inverse. That's the only way to find the angle. You got to use the inverse. Okay, this one, I got to find angle A, and then I've got to find side B and side C. So if I anchor off of angle B, this is going to be my opposite. This will be my adjacent, and this is going to be the hypotenuse. So angle A is going to be easy to find. Just do 90 take away 51, and that's got to be 39 degrees. So those both have to add to 90. Okay, now I want to try and find the hypotenuse. So I'm going to use adjacent. I'm going to use this 12.1 and the hypotenuse, and that is going to be adjacent hypotenuse is going to be cosine. So I'm going to use cosine of this angle, 51 degrees. Cosine equals adjacent over hypotenuse. I just barely did a problem like that, so I'm going to times real quick by x. I'm going to have x times the cosine of 51 degrees is equal to 12.1. Divide both sides by cosine of 51. So 12.1 divided by the cosine of 51. And I am at 19.2. So that's the hypotenuse, that's little c. Little c is 19.2. Okay, now I'm going to find the sine. So I got to find this opposite, so I'm going to use opposite and hypotenuse. So I'm going to do the same angle. So I'm going to use a different trig function. Sine of 51 degrees equals opposite over hypotenuse. Now this one's much faster because it's one step less. If your x is on the top, now I'm just going to times this side by 19.2 and times this side by 19.2. So on my calculator, just punch in 19.2 times sine of 51. And I end up with 14.9. Okay, this one, I have no angles, so now I'm going to have to use the inverse. And I'm going to go from here. I'm going to go from A. So this is going to be the opposite. This will be adjacent, and right here is my hypotenuse. So I need to find angle A, angle B, and what else do I need to find? Side C? Okay, so if I am going from angle A, I'm going to use the trig function that uses 3 and 6.5. So I'm going to use tangent. Tangent of angle A is equal to, what is tangent? Opposite over adjacent. I wonder if I did that other one backwards. Or have we even used the tangent yet? Oh, okay, I think I did it right. So tangent is opposite over adjacent. So tangent of B is going to be opposite over adjacent. Alright, we're in good shape. Okay, so I got the fraction set up right. 3 over 6.5. Now the only way to solve for A is to do the inverse tangent of 3 over 6.5. So now in your calculator, punch in inverse tangent of 3 divided by 6.5. And we should get that angle is about 24.8 degrees. So now I'm going to find the angle B real quick. I'm going to do 90 degrees minus 24.8 degrees. And it should end up with 65.2 degrees. So my last move, I got to find the hypotenuse. And I can either use opposite hypotenuse or adjacent hypotenuse. Doesn't matter. So I'll use sine. So let's do the sine of angle A, which is 24.8. Sine equals opposite 3 over hypotenuse. That's x. So times both sides by x. X times the sine of 24.8 is 3. And by now, you can just realize you're going to really just swap x and sine of 24.8 places. So you can just do on your calculator 3 divided by sine of 24.8, and that will happen every time. So 3 divided by sine of 24.8, we are 7.2. And that makes sense. You know the hypotenuse is going to be the biggest side. These other sides are 3 and 6.5, so that's kind of right in the ballpark. That sounds good. Okay, now we're going to move into any angle. So, I guess some multiple choice, I guess. A negative 135 degrees. The trig that we are going to do is going to be on this 90-degree triangle right here, and this is the angle I want, because that's the angle I'm going to do my trig from. Okay, so 135, I know if I keep going, it's a total of 180. So I'm going to find the difference between that 180 and 135, and it should be 45. So I know this little sliver right here is a 45-degree angle. And if it is a 45-degree angle, I know it's half of a square. And I can make up any dimensions I want for this square. So if I want it to be 2 by 2 by 2 by 2, we're in good shape. We can do that. But now, this is actually -2, and this is actually -2. Because I'm going 2 to the left, and then I'm going to go down 2. So if this is -2, this is -2, my hypotenuse is always going to be positive, and it's going to be 2 square roots of 2. So the cosine is adjacent, which is this -2 right here, over hypotenuse, 2 square roots of 2. But you can't have a square root of 2 on bottom, so I'm going to times the bottom by square root of 2 times the top by square root of 2. These 2's are going to divide out. They're just going to give you 1. So you got negative square root of 2 on top and square root of 4 on bottom. So you got negative square root of 2 over 2. And that'll match up with B. Okay, now if we look at negative 330, so the angle we're interested in is this sliver right here, because we're going to do the trig off of this 90-degree triangle. So I know a full circle is negative 360. So if I find the difference between the full circle and that partial 330, I know this has to be 30 degrees. Okay, now 30 degrees is half of an equilateral. And an equilateral, I'm going to make them all 2, 2, 2. So if they're all 2, I know this is going to be 1 and this is going to be 1. And I know this is going to be 1 times the square root of 3. And in this triangle, everything's going to be positive. We're in quadrant 1, everything's positive. So cosine, we want y over r. No, that's sine. Cosine is adjacent over the hypotenuse. So adjacent is not your y, adjacent is your x. So cosine is going to be x over r. So my x is going to be square root of 3, and my r is going to be 2. And then that's going to match up with d. Okay, now secant of 11 pi's over 3. Hopefully you recognize that's in radians. So let's maybe either count by radians or switch it to degrees. So maybe we'll do one of each. If we're going to change it to degrees, we're going to multiply by 1. So we're going to times by a fraction. The fraction we're going to use is 180 degrees over pi, because pi on bottom is going to cancel pi on top. And I know 3 on bottom and 180 on top, they'll simplify. 180 divided by 3 is going to be, that's going to change to a 1. And that's going to change to a 60. So now I'm just going to times the top, so I'm going to have 60 times 11. So 60 times 11 is going to be 660 degrees. Okay, secant, the fraction they want, secant is the reciprocal of cosine. And we just found cosine to be x over r. So secant is going to be r over x. Okay, now 660, that's more than a circle. So I'm going to take away a circle, and that gives me 300. So 300 degrees. So if I start right here, and I open up to 300 degrees, I'm in quadrant 4. So right here is a 300 degree angle. Now the trig I'm going to do is going to be on this 90 degree triangle right here. And this is a 60. So this is my 30. And that means 30, 60, 90 is half of an equilateral. Here's my other half. And every side is going to be whatever I want it to be. So I want them all to be 2s. So this is going to be 1, that's going to be 1. And this is going to be 1 square root of 3. But because it's going down, it's going to be negative. So the r is going to be my hypotenuse, that's the radius, that's 2. And the x is going to be 1. So 2 over 1, or just 2. Okay, pi over 2. So I know this. I know 180 is equal to pi. So if I'm taking pi, or I'm taking 180, and I'm cutting it in half, I know my angle that we're looking at is a 90 degree angle. Okay, now 90 degree, that's a tough one, because that lands right, this lands right on the line. So for example, let's look at an 80 degree. If I look at an 80 degree, I'm going to come perpendicular to the x, so this is my y, and this is my x, and this is my r. But if you put your finger on this and you open it up to the 90, your y is going to get taller, but your x is going to disappear. And in fact, if you land right on 90, you're not even going to have an x. Your x is going to shrink to nothing. So if I open this up, I land it right on 90, my r is going to equal my y, but my x is going to be 0. And r and y can be any dimensions you want. It could be 10. They don't matter. So the cosine again, cosine is x over r, and x is 0, and r is 10, and 0 divided by 10 is going to give you 0. So if they land right on a quadrant, try and think of an angle that's just either a little bit more or a little bit less, and then that'll kind of help with the visual. Okay, cosine of negative 5/6. So if I divide pi into 6 pieces, I know that 6 times 30 is 180. So here are my pieces. If I divide it into 6 pieces, every piece is 30 degrees. So check this out. If I have 5/6, there's a 30, there's a 60, there's a 90, that's 1, 2, 3 pieces, 4 pieces, 5 pieces. This is the one I'm on right here, but I forgot it's a negative, so we gotta rotate the other way. We went the wrong way. So here's one piece, there's 30, 60, 90. Now we're going this way. 90 plus 30 is 120. 120 plus 30 is 150. So I want 5 of these pieces. 1, 2, 3, 4, 5. This is the one I want. Okay, so I'm going to do trig on this triangle right here. I'm going to make a 90, and if this is 150, I know this has to be a 30 degree because 150 and 30 is going to be 180. Okay, now if it's 30, I know that it's half of an equilateral, and here's my other half. So I'm going to get the eraser, kind of erase some of this stuff. So the triangle I'm looking at is right here. I'm going to make it a 10 by 10 by 10. So if it is a 10 by 10 by 10, I know this piece is 5 and this piece is 5. But because I'm in quadrant 3, this is a negative 5 because I'm going down. And then this piece is going to be 5 square roots of 3. But because I'm going left, it's going to be negative. Okay, cosine, man, we do a lot of cosine. The cosine is x over r. So x is negative 5 square roots of 3, and r is 10. And then let's simplify 5/10, and let's change that to a negative square root of 3 over 2. 5/10 is 1/2. Okay, this is on your last test, using trig to figure out how long this ramp has to be. So if this is 90, we want to find this right here. So I'm going to anchor from this angle. This is going to be my opposite. This is going to be the hypotenuse. And this will be the adjacent. Okay, now I know the loading dock is 4 feet. So if that's 4 feet tall, I'm going to use 4 and this. So opposite and hypotenuse, I'm going to use sine. So the sine of 32 degrees is going to be opposite over hypotenuse. And because I've done this a million times, I know that x is going to be 4 divided by the sine of 32. So punch in 4 divided by sine of 32. And this ramp, you have got to make it exactly 7.54832 feet. long, so we'll call it 7.5 feet. Okay, now we're going to give you a point. So this point 2 square root of 5, here's what you're looking at. You need to look at this triangle. And this is over 2 and up square root of 5. So we need to find, so it's not really looking at angles. Now you're just looking at sides, you're looking at lengths. And I need to find this piece, and I'm going to use Pythagorean Theorem because there's a 90. So I'm going to go 2 squared plus square root of 5 squared. That's going to be c squared. So I'm going to go 4 plus 5 equals c squared. 9 equals c squared. Square root, so c's got to be 3. So this is going to be a 3. Okay, now the cosine, again, is x over r. So my x is 2 and my r is 3. So 2/3. Okay, same thing. Now you got to draw your own picture. They want the tangent of 3, 4. Okay, tangent is actually opposite over adjacent. I mean, check this out. Opposite, that's the height. That's my y. And adjacent is your horizontal. That's your x. So this is your x and this is your y. So the tangent I know is just going to be 4 over 3. I don't even need to draw a picture. But you can. So I'm going to go over 3, up 4. There's a dot right here. Your triangle's got to look like this. It's 3, 4 tall. And you don't really need to find the hypotenuse because the tangent just wants opposite and adjacent. Alright, now we're talking cosecant. Cosecant is the reciprocal of sine. And I know the sine is the height of the triangle over the radius. So the cosecant must be the radius over the height. So 0, 3. 0 up 3. 1, 2, and this one we just did. So it's going to land on 90. It's going to land right on quadrantal angles, so it's going to be a little tricky. So remember, if I take this, if I take a length and I swing it, touch this point and swing it so it lands right here, your r could be 20, but the y will also be 20, but your x will be non-existent. There will be no base. So the radius and the height are the same thing. So the cosecant, they want the radius and the height, so they want 20 over 20, or whatever numbers you choose. No matter what you choose and I choose, we should end up at 1. Tangent of negative 20 and 0. So this picture, negative 20 is clear over here, and 0, so that's the same idea. It landed right on 180. So let's pretend it landed not on 180, but somewhere above it. Now if I grab this point with my finger right here and I move it and swing it so that it lies right on 180, this time this is my r. As I swing it and land it right on 180, the height, this is the y, is going to shrink, but the x is going to get bigger and bigger. So as I bring this side down, my height is going to be, my y is going to be 0. There's not going to be a height, but my x is going to equal whatever the r is. Okay, tangent. Tangent wants the height over the horizontal, the base. So y over x, 0 over 10, whatever you made x. It doesn't matter because it's going to be 0. So we should have done one where there was 0 ends up on the bottom. If 0 ends up on the top, it's always going to be 0. But if 0 ends up on the bottom, then it's going to be undefined. You cannot divide by 0. Okay, last one. Let's find the area of each triangle to the nearest tenth. So area is going to be base times height divided by 2. But the only way you can find height is if you have a perpendicular. And this is going to be a pain in the butt, but hopefully you remember the formula we came up with. So you're going to choose an angle. If I choose this 16, then I must choose 2 sides that go with it, my adjacent sides. So remember this, the area equals 1/2 times, if I use angle C, so the sine, and we're always using sine of angle C, I guess I don't need to put the degrees, but then you're going to use the side B and the side A. So you can use an A and a B and a C, one of each. Or you could do 1/2 times a little a and a little c, but then if you do little a and little c, you've got to do the sine of angle B. Or 1/2 of the little b times the little c, but then you would have to do the sine of angle A. So you must use one of each. And as long as you use the adjacent sides, you're in good shape. So each of these 3 will give you the same answer. So the area is going to be 1/2 times the base, and it does not matter if I call 28 the base or 29 the base, because I'm going to get the same answer, times the other side, 29, times the sine of 16 degrees. So if I punch this in, that will calculate the area for me. And I got 111.9 inches squared. Okay, one more. I'll just use these 3. So I'm going to do 1/2 times 30.1 times 35 times the sine of 29. So 0.5 times 30.1 times 35 times the sine of 29. And for this one I get 255.4 centimeters squared. And that's it. So make sure you know all that stuff and you'll be in good shape.